Hello everybody, welcome to this vlog. My name is Satya. So today we'll discuss, as part of this vlog, we'll discuss about how the packet flow happens for layer 2 bridging in VXLAN and layer 3 routing using VXLAN, right? So let's start looking into the concept itself. So the introduction to VXLAN basics have been covered in the previous video. I will put a link to that video in this video description box so you can follow that presentation before this one. So we were discussing about this particular diagram, right? So we had the data centers represented as VM A1, VM A2, VM B1, VM B2, VM C1, VM C2, VM A3, VM A4. So as the naming suggests, VM A1, A2, A3, A4 are in the same subnet. So they will use layer 2 bridging for transmitting the packets. But if you want to transmit a packet from VM A1 or A2 to VM B1 or B2 or V1C1 or VMC2, then you need to use layer 3 routing, VRF, right? Virtual route forwarding technique. So let's start looking into layer 2 bridging. Let's take an example that VM A1 wants to send a packet to VM A3, right? So the classic example why we should use layer 2 networks is scalability and the faster processing of packets in the intermediate routers, right? Always layer 2 is faster than layer 3 traffic because of the extra header that we have, or to certain extent the data plane forwarding is done in most of the intermediate routers for layer 2 at the data plane. It will not go to the control plane. So let's take the example that VM A1 wants to communicate to VM A3, right? VM A1 is on leaf 1 and VM A3 is on leaf 4. When let's assume that ARP resolution is done, because ARP resolution was clearly explained in the previous video, which the description box will contain the link for that video. So refer that video for ARP packet. What is ARP? ARP is address resolution protocol to convert IP address to MAC address. Here now what we'll do, we'll send from 10.10.10.11 to 10.10.10.13. ARP resolution is already done. They are in the same subnet, both the IPs. So they will send the direct host MAC. They'll use the direct host MAC as a destination MAC, and it will send to leaf 1. Leaf 1 or the switch part, it will check if the destination MAC is gateway MAC its own MAC, or it's a host MAC. Anything other than gateway MAC, it'll consider as a host MAC, and he will see that it's a layer 2 bridging, and it will check for layer 2 bridging what is a VNI. The VNI is same. So the VNI for leaf 1 and leaf 2 is VNI 10010. The VNI will not change for layer 2 bridging. In the same subnet, it will be always same VNI. So it will forward that. Using that VNI, it will forward it to the destination VTAP, that is 10.255.1.4, right? Then he will strip the VXLAN header and give it to VM A3, which is 10.10.10.13, right? That's how the packet decision happens for layer 2 bridging. Let's suppose we are sending a packet from 10.10.10.11 to VM B1 10.20.20.11, then it will send it to the gateway MAC. Here, once he sees the gateway MAC, leaf 1, once he sees it, it's a destination MAC is gateway MAC, he will consult the VRF associated with that L3 routing. In VRF, for reaching 10, 20, 20 8.11 segment, you have to reach through a particular VNI. That mapping will be done. So that VNI will be used to see which VTEP it has been mapped to. So all this L3 routing is populated using the EVPN attributes, right? BGP plus EVPN attributes. So it will find out the VTEP is 10.255.1.2 and it will send it to this VNI. It will change the VNI, right? And then VM will process the packet after receiving it, that is at the VM B1. So this is how a layer 2 bridging and a layer 3 forwarding happens at the leaf 1 using BGP VPN from the spine network, right? So this is what I wanted to discuss, friends. Thank you for your time. Bye.